What if I told you thus that somewhere beneath one of the most crowded cities on Earth, a silent force is building, not tomorrow, not someday, right now, in just 90 seconds. An entire capital city could change forever. No sirens, no flashing red alerts, no dramatic countdown clock, just a low rumble beneath your feet, and then chaos. Over the past several weeks, 847 earthquakes have shaken parts of the Philippines. Most were small, barely noticeable, a quick tremor, a passing vibration, easy to ignore. But the Earth doesn't ignore pressure. Every small quake is a signal. Every microfracture is movement. Every shift transfers stress somewhere else. And that somewhere may be the most dangerous place imaginable. Directly beneath Metro Manila lies the West Valley Fault, a massive tectonic boundary capable of unleashing a magnitude 7.2 earthquake. Scientists at PHIVOLCS have warned about it for years. They call it the Big One. Not because it sounds dramatic, but because the models are. Their simulations show up to 90 seconds of violent ground shaking, bridges twisting, buildings collapsing, millions scrambling for safety. And here's what makes this moment different. Seismic data now shows increased stress loading across nearby fault systems. In simple terms, the pressure is rising. Tectonic plates don't move smoothly. They lock, they grind, they resist, until friction fails. When that happens, centuries of stored energy release in seconds. That's not fear-mongering, that's physics. The West Valley Fault hasn't ruptured in over 300 years. History tells us it doesn't stay silent forever. The question isn't if the Earth will move, the question is when. And tonight, we're breaking down the science, the warning signs, and the very real probability spike that has experts watching closely. Because when the ground finally shifts, those 90 seconds won't feel short. They'll feel endless. Stay with me. What you're about to see could change how you look at the ground beneath your feet, forever. The Philippines sits on one of the most volatile tectonic crossroads on the planet. This isn't just another earthquake zone. This is where massive sections of the Earth's crust collide, grind, and lock together under unimaginable pressure. And running directly beneath Metro Manila is one of the most dangerous fault systems in the country, the West Valley Fault. At first glance, it looks invisible. Just a line on a geological map. But beneath the surface, it is anything but quiet. The West Valley Fault is capable of generating a magnitude 7.2 earthquake, powerful enough to rip through the heart of the capital region. According to projections from PHIVOLCS, when this fault finally ruptures, it could directly impact more than 14 million people. 14 million. That's not just a statistic. That's families. Children in classrooms, workers in high-rise offices, patients in hospital beds, commuters stuck in traffic. Now picture this. It's a normal day in Metro Manila. The air is humid, traffic is dense, life is moving fast. Then the ground begins to tremble. At first, it feels small, almost like a heavy truck passing nearby. But within seconds, the shaking intensifies. Buildings begin to sway violently from side to side. Windows shatter outward. Concrete cracks like glass. Roads split open as the fault tears across the surface. Power lines snap. Transformers explode in flashes of blue light. Elevators freeze between floors. Inside hospitals, equipment rattles violently. Patients are rushed away from falling debris. Emergency rooms flood with the injured within minutes. And here's the part most people underestimate. It wouldn't last hours. It wouldn't be an all-day disaster. The strongest shaking would last approximately 90 seconds. That's it. But 90 seconds of sustained high-intensity lateral movement is more than enough to cause catastrophic structural failure, especially in densely populated urban zones. Earthquakes don't need hours to devastate cities. They need stored energy, and the West Valley Fault has been storing it for centuries. This fault hasn't produced a major rupture in over 300 years, which means pressure has been accumulating silently beneath the surface, generation after generation. Geologists call this elastic strain buildup. When rocks along the fault are locked, tectonic plates continue moving. Energy accumulates like a stretched rubber band, and when friction can no longer hold it back, it snaps. When that snap happens, history doesn't slowly change, it shifts instantly, because those 90 seconds won't just shake buildings, They could redefine an entire nation's future. And that's why experts don't call it possible, they call it inevitable. Now here's where things start to escalate. Over the past several weeks, more than 847 earthquakes have struck regions across and around the Philippines. Most of them were small, magnitude 3, magnitude 4, some barely noticeable unless you were standing still. For many people, they felt insignificant, a quick vibration, a passing tremor, nothing alarming. But here's what most people don't realize. Small earthquakes don't automatically mean safety. In fact, sometimes they mean the opposite. There's a common myth that minor tremors release pressure and reduce the chance of a larger quake. That sounds comforting. But it isn't always true. In complex fault systems, small quakes can actually redistribute stress, shifting it from one segment of the crust to another. Think of tectonic plates like massive, interlocked gears buried miles underground. They don't move smoothly. They grind, they resist, they lock in place. And when one gear slips slightly, the pressure doesn't disappear. It transfers. Imagine tightening bolts across a steel bridge. If one bolt loosens slightly, the strain shifts to the others. The structure is still under stress, sometimes even more than before. That's how stress transfer works inside the Earth. Each small quake is a tiny adjustment in a massive system under tension. And when those adjustments occur near a major fault, like the West Valley Fault, scientists pay very close attention. Because stress doesn't vanish, it migrates. Seismologists analyze what's called Coulomb stress transfer, a measurement of how one earthquake increases or decreases pressure on surrounding faults. Recent seismic patterns show increased loading across key zones near Metro Manila. That doesn't mean a major quake is guaranteed tomorrow, but it does mean the system is active, very active. And here's the crucial part. Scientists cannot predict the exact day or hour an earthquake will strike. There is no countdown clock, but they can measure accumulation. They can track strain. They can monitor fault creep, microfractures, and seismic clustering. And right now, the data indicates elevated stress across several interconnected segments. It's like watching storm clouds gather. You don't know exactly when lightning will strike, but you know conditions are becoming favorable. That's why experts aren't panicking, but they are watching closely. Because large earthquakes rarely happen without warning signs in the data. The signs aren't dramatic headlines. They're patterns, clusters, frequency shifts, subtle increases in seismic energy release. And when hundreds of small quakes occur within a relatively short window, it signals movement within the system. The Earth is adjusting, the plates are shifting, and beneath Metro Manila, one of the most dangerous faults in the region remains locked. For now. But the more stress that transfers toward a locked fault, the more energy it stores. And when stored energy exceeds friction, release becomes inevitable. 847 earthquakes may not have caused widespread destruction, but they may have done something far more significant. They may have loaded the spring, and when a spring is compressed long enough, it doesn't gently unwind, it snaps. Let's slow this down, because when it happens, it won't feel fast, it will feel endless. You're in Metro Manila, it's an ordinary afternoon, traffic is gridlocked under the heat. Motorcycles weave between cars, inside shopping malls families move between stores, students sit in classrooms, office towers hum with routine, everything feels stable, solid, permanent. Then, a low rumble, not loud at first, almost like distant thunder beneath your feet. Some people pause, others ignore it. Then the floor begins to vibrate, ceiling lights sway gently. A few seconds later, the vibration turns into shaking, and then, violent horizontal force, not up and down, side to side. That detail matters, because the West Valley Fault is a strike-slip fault. That means the ground doesn't just bounce, it tears laterally. Imagine the Earth suddenly sliding several feet in opposite directions beneath a city of millions. Glass explodes outward from high-rise windows. Concrete columns crack under torsional stress. Vehicles slam into each other as roads ripple like waves. People lose their balance instantly. You cannot stand, you cannot run, you can only drop. Within 20 seconds, panic spreads faster than the shaking itself. Alarms blare, car horns jam, power flickers. By 30 seconds, structural weaknesses begin revealing themselves. Older buildings, especially those not retrofitted for lateral movement, start to fail. Walls separate from frames, parking structures twist, Elevated roads buckle, dust fills the air. At 45 seconds, communication networks overload. Cell towers shake, signals drop. At 60 seconds, the destruction escalates. Sections of poorly reinforced buildings collapse. Bridges sustain critical stress fractures. Gas lines rupture beneath city streets. And the shaking is still happening. Still violent, still relentless. By the time 90 seconds arrive, entire neighborhoods in high-risk zones could be partially or completely destroyed. 90 seconds doesn't sound long, but sustained lateral ground acceleration at that magnitude is catastrophic in dense urban environments. Seismic hazard models project tens of thousands of potential casualties, hundreds of thousands displaced. Critical infrastructure failures across transportation, healthcare and utilities. Water systems compromised. Power grids offline. Emergency services overwhelmed. And then come the aftershocks, because major earthquakes rarely arrive alone. This isn't exaggeration. It's based on urban impact simulations conducted using historical fault data, population density metrics, and structural vulnerability mapping. When scientists model a magnitude 7.2 rupture along this fault, the numbers are sobering, not dramatic, not cinematic, mathematical. This isn't about fear, it's about physics meeting infrastructure. When stored tectonic energy releases beneath one of the most densely populated regions in Southeast Asia, 90 seconds becomes more than a minute and a half. It becomes a turning point, and once those seconds pass, recovery could take years. Here's the uncomfortable truth. Earthquakes don't destroy cities, weak structures do. Metro Manila is a megacity, dense, vertical, constantly expanding. Over the decades, millions of people have moved into the region. Skyscrapers rise, highways stretch outward. Entire districts have been built in record time, but rapid growth comes with trade-offs. Not every structure was built under the latest seismic engineering standards. Some buildings are reinforced, many older ones are not. And in a strike-slip earthquake like the one expected from the West Valley Fault, lateral motion is the real killer. Side-to-side acceleration twists frames, shears columns, and stresses joints in ways older designs were never meant to withstand. Modern seismic codes account for this. Older structures often don't. But structural age isn't the only issue. There's another invisible threat beneath the city. Soft soil amplification. Certain parts of Metro Manila are built on reclaimed land, river deposits, or loose sedimentary layers. Unlike solid bedrock, soft soil behaves like gelatin during intense shaking. When seismic waves pass through it, they slow down, and when waves slow, their amplitude increases. In simple terms, the shaking gets stronger, sometimes 2 to 3 times stronger than areas built on stable rock. So a magnitude 7.2 earthquake may not feel uniform across the city. In some districts, it could feel dramatically more violent. That difference can determine whether a building cracks or collapses. And then there's infrastructure. Bridges, overpasses, rail systems, airports, hospitals. These aren't just buildings. They're lifelines. If a bridge fails, emergency vehicles can't move efficiently. If hospitals sustain structural damage, medical response capacity drops instantly, right when it's needed most. If airports are compromised, external aid becomes delayed. Infrastructure failure creates cascading consequences. Power grids are interconnected systems. If one substation goes down, it can trigger widespread blackouts. Water systems rely on pumps and pressure lines. Damage underground can leave millions without clean water. Telecommunications towers depend on stable foundations and backup power. Without them, coordination collapses. In disaster science, this is called systemic vulnerability. It's not just about the initial shaking, it's about how interconnected systems fail under stress. Metro Manila's density amplifies this risk. High population concentration means more people exposed per square mile. High-rise living means vertical evacuation challenges. Narrow roads mean slower emergency movement. When critical infrastructure fails in a city this dense, recovery doesn't just become difficult. It becomes exponentially harder, because restoring one system depends on another already damaged system functioning properly. And here's the reality. The earthquake itself may last 90 seconds, but the vulnerability built over decades determines how severe those 90 seconds become. Nature provides the force. Urban design determines the outcome. That's why experts don't just study the fault line. They study the city built above it. Because in a major seismic event, the difference between damage and disaster isn't magnitude alone. It's preparedness meeting pressure. And right now, that equation is being tested. Let's address the question everyone is thinking. Can scientists predict exactly when the big one will strike? Here's the honest answer. No. There is no countdown clock hidden in a laboratory. No secret calendar with a red circle around a date. Earthquakes do not follow human schedules. But that doesn't mean we're blind. While scientists cannot predict the exact day or hour, they can measure probability. They can measure stress. They can measure strain. And probability changes over time. The fault beneath Metro Manila, the West Valley Fault, hasn't produced a major rupture in more than 300 years. That matters, because geological trench studies, sediment displacement analysis, and historical records suggest recurrence intervals of roughly 400 to 600 years for major events along this system. In simple terms, large earthquakes along this fault tend to happen within that time window. We're already deep inside it. Now here's something important to understand. A recurrence interval is not a timer. It doesn't mean the earthquake will strike exactly at year 400 or year 600. It means that statistically, once a fault enters that range, the likelihood increases compared to earlier periods. Think of it like a stretched rubber band. When you first start pulling, there's tension, but it holds. The longer you stretch it, the more potential energy builds. At some point, the material reaches its limit, and when it snaps, it doesn't give a warning sound first. It simply breaks. Tectonic plates behave similarly. The Earth's crust along a locked fault continues moving millimeters every year. But if the fault itself is stuck due to friction, that movement doesn't disappear. It stores as elastic strain. Over decades, stress accumulates silently beneath cities that continue growing above it. And here's the key principle. When accumulated stress exceeds the frictional strength holding the fault in place, failure becomes inevitable. This isn't speculation. It's basic rock mechanics. It's what scientists call elastic rebound theory. The same principle confirmed after major earthquakes worldwide. The ground deforms gradually, then suddenly releases. That sudden release is the earthquake. The West Valley Fault has been accumulating strain for generations. Geodetic measurements, GPS tracking, and seismic monitoring all suggest it remains locked in critical sections. Locked means pressure is building, not releasing. So while scientists cannot say, it will happen on this date, they can say something equally powerful. The statistical window is open. And once a fault enters its expected recurrence range, each passing year without rupture does not eliminate risk. It increases stored energy. That's tectonic law, not dramatic language, not headlines, physics. The Earth operates on stress and friction, and when friction loses, energy wins. The only uncertainty left is timing. Here's the part almost nobody prepares for, because most people imagine the earthquake as the disaster, but often it's only the beginning. When the shaking finally stops, there's a moment of silence. Dust hangs in the air, car alarms echo, people freeze, and for a few seconds, it feels like maybe it's over. It's not. Because once the ground stops moving, secondary disasters begin. Gas lines rupture beneath broken streets. A single spark can ignite entire blocks. History has shown this again and again. Fires after major earthquakes often cause devastation equal to or worse than the initial shaking. Electrical grids, already strained by violent motion, short-circuit. Transformers explode. Power goes dark across entire districts. Without electricity, traffic systems fail. Signals go out. Intersections become gridlock, and that gridlock becomes deadly, because rescue teams can't move. Ambulances struggle through collapsed overpasses and debris-filled roads. Firefighters face blocked routes and broken hydrants. In dense areas, narrow streets become choke points. Minutes matter after a major quake, but infrastructure damage steals those minutes. Then come the hospitals. Emergency rooms flood with injured victims within the first hour. But what if the hospital itself has sustained structural damage? What if operating rooms are unsafe? In past major earthquakes worldwide, medical teams have been forced to triage patients in parking lots, tents, even sidewalks. When medical systems are overwhelmed, survival rates drop, not because injuries are untreatable, but because capacity is exceeded. Communication networks overload almost instantly. Millions of people try to call loved ones at the same time. Cell towers shake, backup power fails, signals crash. In a city like Metro Manila, that communication breakdown amplifies panic. Rumors spread faster than verified information. Fear becomes contagious, and fear changes behavior. People rush home, rush into streets, rush toward loved ones. Crowds surge through unstable areas. Aftershocks hit, sometimes nearly as strong as the initial quake. Structures already weakened collapse completely. Each aftershock resets the terror. But here's what disaster research consistently shows. Secondary effects, fires, infrastructure collapse, medical overload, supply chain disruption, often cause as much damage as the primary earthquake itself. Water systems break. Without clean water, sanitation declines. Without sanitation, disease risk rises. Grocery supply chains stall, fuel deliveries halt. What begins as a geological event becomes a humanitarian crisis. And this is why preparedness isn't dramatic, it isn't paranoid, it's practical. Because earthquakes don't just test buildings, they test systems, they test coordination, they test resilience. The shaking may last 90 seconds, but the aftermath can last months, sometimes years. Preparedness isn't optional, it's survival. Because when the ground stops moving, the real challenge begins. Let's shift from fear to control. Because while you can't stop tectonic plates, you can control how prepared you are when they move. If you live in or near Metro Manila, preparation is not extreme. It's intelligent. Start with your immediate environment. Secure heavy furniture to walls, bookcases, cabinets, large appliances. In strong lateral shaking, unsecured objects become projectiles. Most household injuries during earthquakes come from falling items, not collapsing buildings. Next, build a 72-hour emergency kit. Why 72 hours? Because after a major urban earthquake, emergency response systems can be overwhelmed. It may take days before consistent aid reaches every neighborhood. Your kit should include water, at least 1 gallon per person per day, non-perishable food, flashlights with extra batteries, a first aid kit, medications, portable phone chargers or power banks, important documents sealed in waterproof storage. Know your evacuation routes from your home, workplace, and school. During a disaster, confusion wastes precious time. Clarity saves it. And practice the most important immediate response technique. Drop, cover, and hold on. Drop to the ground before the shaking knocks you down. Take cover under sturdy furniture. Hold on until the shaking stops. Do not run during violent shaking. Most injuries happen when people attempt to move, and store water, not just a few bottles, a reliable reserve. Because after major infrastructure damage, clean water access becomes uncertain fast. Here's the reality. Earthquakes don't send warnings, they don't offer countdowns, but preparation transforms chaos into action. The difference between panic and survival is planning, and planning starts before the ground moves. So here's the question that lingers in every mind. Will the big one happen tomorrow? Maybe not. Next year? Possibly. In our lifetime? Very likely. And that's not drama. That's probability. The West Valley Fault has remained locked for centuries. Stress has been accumulating silently beneath millions of lives. The Earth doesn't operate on news cycles. It doesn't care about election years, economic trends, or busy schedules. It moves according to physics. Stress builds, friction resists, rock bends. And when friction can no longer hold that stored energy, it fails, suddenly, violently, without negotiation. When tectonic limits are reached, the release doesn't unfold slowly over days. It happens in seconds. That's what makes earthquakes uniquely powerful. No countdown, no gradual warning siren, just a rupture. And in those seconds, decades of accumulated energy are unleashed. The only true uncertainty isn't whether the fault will move, it's when. And when it does, everything changes at once. 847 earthquakes, stress rising, a fault line beneath millions. This isn't about fear, it's about awareness. Because when the ground moves, only preparation stands firm. If you found this breakdown valuable, share it with someone in the Philippines. Stay informed, stay prepared, and remember, the Earth doesn't send invitations, it just moves.